Welcome everyone. Good afternoon. I hope everybody's had a good meal. I'm always fearful of a speech after a meal. I've told him that I'm not expecting people to sleep here. But hopefully I'll wake you up. Right? My name is Jayaprasad Hegde. I head the Data Science and AI initiatives at NPCI. Uh, Go back a second, please. And the topic that I've chosen here is a story of our own, the story of our data science team, and what were the reasons that we sort of scaled to be a world-class team. At least we considered it world-class, and we'll show you why. So I'm here to tell you about AI at a billion people scale. Right? If you are at NPCI, there is no option but to work at a billion people scale. So quick introduction about myself. I come from a very multi-generational AI background. I started my career at an AI lab. So I started working on things like genetic algorithms, transfer grammar-based machine translation, things like information extraction, building parsers from the ground up, right? Building everything yourself, and that's the culture that I come from. Move to like very machine learning approaches to machine translation, information retrieval approaches, information theory approaches, right? And which you see still have a role to play today, but less so in the world of like LLMs and all. And more recently, multiple initiatives starting with things like even revamping the AI platform from the ground up. Traditional ML still continues to play a role in my life. Things like deep learning now have a more say in the overall things that I'm doing right now. And very interesting newer things that you possibly see on the horizon like graph AI, generative AI and so on. Now something about NPCI, I think everybody knows NPCI from the jewel in the crown, right? The UPI story, for instance. We had a keynote in the morning talking about the UPI story, the IMPI story. But NPCI is a digital payments infrastructure company, right? We are the backbone of most of the things that the citizen takes for granted. So, so things like UPI you already know, things like IMPS you already know, but also things like your checks, right? We operate the backbone for the check truncation system, the check clearance system. I don't think many of us use check anymore, but it's still being used in enterprises. NACH, every time an EMI goes through an account, for instance, or every time the government hands over a direct benefit transfer to a needy citizen, right? That goes through something called as the NACH system. NFS, every time you walk with the ATM card into any bank ATM, you're not worried about whether that ATM is going to be, that card is going to be accepted or not. That is due to this system. This is an interbank and ATM switch. If you remember the good old days when your bank ATM could be used only at your bank, with your bank card. And I think those are no more because of this system. And if you go to smaller towns, you'll come across something like Aadhaar-enabled payment systems. So they won't have the ATM features, but they would want to make payments. So they'll possibly go to their nearest merchant who's operating as a proxy ATM, for instance, and sort of retrieve money for their Aadhaar credentials. And of course, RuPay, which happens to be our response to the world, which is our response to the great MasterCards and Visas of the world, where we want to create our own stack, our own credit card, our own debit card stack, and of course our own national common mobility stack. So if you go to the Delhi Metro or Mumbai Metro, you'll understand that the underlying card stack that is being used is the RuPay card stack. You want me to talk loudly, or who's not able to hear? You blame the speaker. There's no speaker here, but not me as a speaker. The other thing that it might be a bit loud for the front audience, but I hope it does it well for the ones who are sitting here. The other things that we also do are your payment, your bill payment, your utility payment, right? Every time you go through a Google Pay or a Phone Pay and you pay an electricity bill, you pay a, let's say, your premium, for instance, that goes through something called as NBBL, NPCI Bharat Bill Pay Limited. And finally, our latest innovation, which is the digital rupee. Now, all of these are India scale projects. And to build for those India scale projects, we have homegrown AI platform which has been built from the ground up. Most of the story is about this today. So we have large data engineering systems, high speed and high volume inferencing needs. We have large We have large training workloads, large analytics. We have a notebook ecosystem for in-house data scientists, fast prototyping at largest scales. If you understand largest scales at NBCL levels, it will be still larger than most companies' works. In-house large infrastructure. And our main motto is we build everything. Literally everything. We build from the data center upward. So we get a bare metal and we start building on top of it. We build a cluster, we build a stack on top of it. So, the gist of today's talk is this: how does a team grow into a large area platform team? Right? We're going to take a narrative look here. So, digital payments has grown sharply, right? Meaning, if you just go from, if I track from, let's say, Jan 2021, 2 billion transactions. Jan 2022, 4 billion transactions. Jan 2023, 8 billion transactions. Jan 2024, 12 billion transactions. Right? That growth is steep. It's almost like QR code is growing on trees here, right? People are like doing digital payment by the bucket loads. But what does it mean for the people behind the curtain? What does it mean to the wizard who's operating things behind the curtain, right? What does it look like for that team who's at the bottom of this data waterfall? So this is a picture of Angel Falls in Venezuela. But this is the perspective. I'm standing at the bottom of this waterfall, looking at the size of this waterfall grow every year and trying to cater for it every year. So we are dealing with super large volumes, which means you need to have resilient systems, zero downtimes, right? I mean, even if there is a downtime, you should be able to recover very, very, very quickly. Which means you need to have redundant structures in place so that even if something goes down, something else takes over. Maybe a cluster goes down here, another cluster takes it up. Maybe a data center, maybe a part of that cluster in one data center is down, you pick another data center to pick up that slack. And at the end of the day, we still want authoritative data at rest, which means once the data has arrived, you know that you can trust it. Now this is one part of the story where we talk about like there are challenges at a data engineering level and you need the team to basically come up to speed to handle that scale. But there are other challenges as well. We know that the digital payment system is growing and the number of people who are trying nefarious activities, they are growing as well. Right? It's no longer only the Jamtaras of the world that are in play. The bad guys are on the prowl. You need to act swiftly and you need to act at scale. Which means the team now also has to evolve into a large-scale inference platform, right? To check this, to stop this if possible. So you need inferences at scale. Right? You need inferences at scale and speed. So if I'm talking about UPI transactions and the volume of UPI transactions that are happening, you need to address that scale, meaning which is every time you are doing a UPI payment, for instance, we are doing a real-time check. And this is a check which does not disturb you at all, meaning there's no experience that has been taken away from the consumer at all. Which means we are operating on a very limited time budget to do our check. So we need to do inferences at speed, inferences at scale, super large scale, inferences at speed. Which means we need a cluster architecture which is built for this scale and this speed. And you need to be always on your guard to scale out when necessary. You understand the challenges. And if you're, this is just the engineering part of the story. I know presenting a small snippet of the engineering challenge here. But the data science part of the story is equally interesting and an interesting story in its own right. So you need high-speed models now. And you need careful selection of the features which go into these models so that they are built, they're purpose-built for speed, and the features have been purpose-built or purposely chosen so that they are capturing the best value or best bang for the buck. Of course, we are talking about inferences, machine learning models. Going to the next part of the story. So, only inference clusters are not enough. So, we talked about engineering for data, we talked about inference clusters now. And you're building machine learning models. But inferences need to be constantly evolving. You're not the only person who's evolving. The bad guys are evolving as well. Which means you need to refresh your models maybe every week, every day, what have you, depending on the needs of the data scientist. You need a cluster where you can train. The data scientists need to train models at a greater speed. So they need a fast training mechanism and they need faster experiments. So which means now you are adding a brand new chapter to the story. Training clusters are needed. We talk about data engineering, we talk about inferences, now we are adding one more chapter, which is the training clusters. So you understand where we are headed, right? The team is gradually evolving into a large-scale AI team. Right? We might have humble origins, humble beginnings, but there's no other option other than to evolve and grow at a pace that meets the needs of the constantly evolving digital payment ecosystem here. We need more teams who are doing experiments. We need more models so that we can pick the best model for the best task. We need more inferences. Which means the data scientists need their own isolated, insulated ecosystem just to go about experimenting without anybody disturbing them. They need their own notebooks. Which means that I have to create notebooks for everyone. It's not like your usual case where somebody just opens up an AWS or a Colab. You go about creating your own notebook. You do your experiments and you're merrily on your way. The guy who's writing the Colab notebook is also in my team. The guy who's creating the infrastructure for the Colab is also in my team. The guy who's fetching data for the training data is also in my team. The guy who's setting up the production cluster for the inferences to go through is also in my team. So which means I'm handling all parts of the story here. It's not just a unidimensional story where you're creating your own ML experiments and you're merrily on your way. I'm using the pronoun I, but think of it as a we. So it's a large team story. Let's go back. So we have isolated models for everybody. We need data catalogs. We need a governance system where one person is not able to disturb another person in terms of their data needs. And we need benchmarks for that data scientist. Right? Every time you're going to create a model, you need to test it against something. And those benchmarks come into the picture. So your data scientist, she might have created a brand new model and she wants to check how a model is performing compared to her earlier version. You would have those benchmarks to help her. And imagine all of these operating in their own insulated, isolated environment. So you have multiple of these experiments going on at any given point of time. And to top it, we all know this, right? AI ML is compute greedy. So scale out for inferencing is always on the cards. And scale out for training is always a demand, meaning your data scientist does not want to work on like smallest training data set. She would always want the best, largest data set which is best for that job. Right? And the negotiation is always on the card side, saying maybe this is not the training data that you need, maybe there's something else which suits you better. Also, the interesting piece that we've all learned is like CPUs are not enough in this day and age. You need to add GPUs to the mix. The days of only using traditional machine learning are long gone. But as soon as you add GPUs to the mix, your stack also changes dramatically. And I'm talking both at a cluster level as well as the software stack. The kind of experiences that you go through to make it happen, from the training set, from the inference side, all changes. The cluster changes, the nature of your experience in scaling out for the training cluster or scaling out for the inference cluster, all changes. Just to recap, growth is inevitable for us. We have growing data needs. We have growing cluster to meet those growing data needs. We need large number of checks, which means we need a large inference cluster. And if you need to bring a strong ML system or a large ML system, a constantly evolving ML system, you need a constantly evolving training ecosystem, which means you need a large training cluster. And if you need a training cluster, which means that you need to create an ecosystem on your homegrown AI platform, which services the needs of every data scientist separately. So you are building a legitimate first-class AI platform from the ground, whether you like it or not. That's my story, right? Whether I like it or not, I have to build this skill. So your notebooks are going to get created for new experiments, and data sets keep getting created for new ML jobs. And to top it, I'll add another wrinkle, right? Meaning, I think that by itself is not enough. We are saying we need to look at macro indicators. We are just looking at maybe a piecemeal transaction, trying to figure out how best we can infer out of it. Can we detect a fraud looking at only a transaction? But you know, the nefarious guys, they're operating at a much macro scale. Maybe there are structures in place that you need to follow. Maybe you need to follow the trail, the breadcrumb, and see where does it go to. So you need thorough checks for much more macro views. So we have the likes of maybe graph AI, deep learning, and some mixed variant of it, right, which enters the system. And you understand where this is headed. You're adding one more cluster to the overall setup. And again, I'm talking in terms of cluster, but please understand the story. We are building everything from the ground up. I get only machines. I have to build the cluster. We have to build the stack. We have to build the inference system, which meets the need of this macro analysis system. Okay? Now, at the end of the day, this has been our journey and our story. And there are aspects of this story which are very interesting. We've not talked in depth about the kind of data at rest stories, for instance, or MLOps stories, or the data ops stories that we come across, the deep learning ops stories, right? Each of that is a different piece by itself. But I wanted to present a much more cohesive view of what has been our journey into becoming an AI team which can handle 1 billion people scale. And this leads to where we stand today. We are a full-fledged AI team with a full-fledged AI platform stack. We do inferences at 1 billion people scale. We allow inferences on either a choice of CPU or GPU or a mix of these clusters. And the experience are varied for each of this, right? The kind of things that we have on the GPU cluster of the story for inferencing don't match the kind of things that we have the GPU cluster of the story for training needs. They are very different. You'll see much more fatter models on the training side of things, much more leaner models on the inference side of things. We allow training on CPU and GPU clusters. we are also allow other AI techniques. I mean, I talked about graph AI, right? That's a whole branch, whole universe of techniques which comes along. So when you talk about traditional models, that's one universe. Deep learning models, that's another universe. Graph is a brand new universe that we have to introduce. We have independent notebooks for everybody. And we have to build for a super large data ingestion and large queries. So of course, there are people who want to ask questions of the data, right? Which means that you are going to ask questions on the huge data lake that has already been formed. That by itself is a big task. I have not even touched on that. I'm just touching on the engineering and the data science pieces of the story, just to bring you a flavor of the kind of challenges that we go through, the kind of stories that we build, and the kind of team that we build, the kind of stack that we built over a period of time to address this. But if you bring this all together, this starts looking like your Vertex AI of Google, for instance, or this is the same thing, right? They're offering notebooks, they're offering you inference environment. But this has been all created in-house. There's no public cloud anywhere. Our start point is a bare metal machine that we get. Our end is this full-fledged AI platform that we release for our in-house data scientists. And I'd like to leave you with this thought, right? This is the kind of effort that goes behind the scenes to serve a billion people universe. And of course, we are ready for even more as we're speaking. And there is a lot of effort which goes on a multi-year front to address data engineering techniques, machine learning techniques, querying techniques, and even things like brand new AI algorithms coming into the picture. I'll leave you with that thought. Thanks a lot. You've been a nice audience.